I asked you to solve this equation. What would you do? Subtract 1. Okay, cool. What do we do now? Square root. All right. You guys like to always check. I saw you. This is good. Check, like maybe this is a perfect square. Okay? So I'm going to check. I'm going to go into my calculator. I'm going to square root -1. What? Non-real answer. What the heck does that mean? Can't square root a negative. It's like the question, what number, think about it this way, what number can I square to get -1?
Nothing.
I can't.
No.
There's no numbers. Okay? And this is very important. There are no numbers that you know of.
That anybody knows.
No? There are numbers. Okay? I'm going to say, you know what, there is a solution. The solution is the square root of -1. But your calculator says, no, you can't do that. But you know what? I'm going to say, this is a number. I'm going to call it I. It's imaginary. We just made it up. I is the square root of -1. And if I plugged in I into this original equation, it's going to work. If I plug in I and I square it and then I add 1, I'm going to get 0 because I is the square root of -1. And if I is squared, root -1 squared, what's that? -1, because the square root and the square will cancel each other out. I win. I win. Turns out I could have plugged in -I as well. Because if I square negative roots -1, I also will just get -1. Add 1, get 0. Though, when you graph x squared plus 1, you see no real solutions. There are solutions if we use this idea of an imaginary number that involves square roots of negatives. Okay? So, we are going to be working with these imaginaries. Okay. So, if you look at an equation like this, x squared plus 4 equals 0. And you graph it, and it's a parabola that's above the x-axis. You no longer will say no solutions. You will say there are solutions. They're just imaginary. They are numbers that we have to create, and mathematicians created these numbers because they're very much applicable in very, very many different fields. Okay? You guys don't have to worry about those applications, but you have to understand and be okay with the existence of them. Where I know that if I plug in the square root of -4, both plus or minus square root of -4, I'm going to have my correct answer. Now, we're not going to say square root of -4. We're not going to say square root of -1. Instead, we will say, you know what? Root of -4, that has the square root of -1 and the square root of -4 part of it. I know the square root of 4 is 2. I am writing the square root of -1 from now on as I. Okay? Cool? We're going to go with it. Now, we will always be able to solve any quadratic, either using real numbers or imaginary numbers. Let's go to our notes. We are now looking at imaginary numbers. Just circle this. Don't worry about this poop. Okay? Imaginary numbers are square roots of negative numbers. They can be placed inside of equations to solve some equations. Namely, we are going to use them to solve quadratics. For example, x squared equals negative 16. It's got no solution that is real. There's no real number solution because the square of any real number is positive. What? This is just dumb. Don't worry about that. So, what we will do is say, okay, well, x could equal plus or minus root negative 16. And we're not going to write it as root negative 16. We're going to say, well, negative 16 is just negative 1 times 16. 16 is just 4. Negative 1 is I. I will say my solutions are plus or minus 4i. Where I is the square root of negative 1. And if I take negative 1 rooted and square it, I just get negative 1. We now have a concept that if we square it, we get a negative number. It won't be that difficult. Trust me. An imaginary unit can be used to find the square root of any negative number. All right, you can fold that in. Okay. When we see square roots of negatives, we are going to split it using a property of exponents and multiplication into the square root of negative 1, and I'm going to do this in a good order, into the square root of the number and the square root of negative 1. Okay? So, root negative 4, I'm going to rewrite. Come on, stay with me, wherever I am. Yes. But no plus or minus just yet. It's when we solve an equation, we'll have a plus or minus. We got square root of 4, square root of negative 1. We know the square root of 4 is just 2. We have deemed that the square root of negative 1 is I. Okay, you guys do number 2, please. The square root of negative 100. We can split it into the square root of 100 times the square root of negative 1. The square root of 100 is 10. The square root, so don't worry about the negative. We're going to split off the negative and just worry about the positive 100. It's 10, and then the square root of negative 1, which is what we'll say is I. So we will write this as the positive number times the square root of negative 1. This can be written as 10i. Now, the next one, the next 2, and we're going to do a couple more because we didn't focus on it for the last class, but we need to focus on it for this class and for the future. It is something that you need to know even for like an SAT or for any type of like placement exam that you'll take, is like simplifying radicals. If I asked you to simplify the square root of 24, you guys first would plug it into your calculator and get a decimal, right? But you know there's actually more that you can do. Okay? Please write down our perfect squares. A perfect square is a number that can be square rooted and you get a whole number, like 4, like 9, 16, 64, but you skipped a couple. 25, 36, 64, we'll stop there. Yeah, we forgot about 49. 25, 36, 49. Okay? Watch what I can do with the square root of 24. Again, using the same type of idea, I could rewrite this as a perfect square times an imperfect square. I know 24 is divisible by 4. and 6. Okay, write down 24 as 4 times 6, both rooted. The square root of 4 is 2. I can write the square root of 24 as 2 root 6. So, if I wanted to simplify the square root of negative 24, watch what I'll do. I'll split it into the positive side and the negative side. Positive root 24, and then negative 1 underneath square roots. I will then take this 24 and write it as root 4 root 6. Root negative 1, I'll say is I. This is 2 root 6i. This is fully simplified. It is the same as the square root of negative 24. We did not do anything to change it, but we need to be comfortable with simplifying it for various reasons in this class. On SATs, simplifying radicals are important to get like a standardized answer. Okay, we'll do a couple more after this. Negative 3 times root negative 50. I'll split this into root 50 and root negative 1. We can split root 50 into a product of 2 numbers, one of which is a perfect square and one of which is not. 25 and 2. Negative 3 times root 25 times root 2 times root negative 1. Is everybody comfortable with that? I'm going to give us a couple more after this. This then becomes negative 3 times 5 times root 2 times I, or negative 15 root 2i. This is like a standardized form of what we just saw above, up above. Okay? We're going to do a couple more. To the side here. I'd like you to simplify negative root 48, please. Everybody do it. Find a perfect square that goes into 48. Find the largest perfect square that goes into 48. Please write it down and do it. 12 times 12 is 144. My advice is to start with 48. Using your calculator, start dividing by our perfect squares. So example, 48 divided by 25. What? 48 divided by 25. All right, that doesn't work. So then I go down. 48 divided by 16. Does that work? 48 divided by 9. Does that work? 48 divided by 4. Does that work? Eventually one of them is going to work if I can simplify it, or else I don't. Go. I'll give you another one after this. 16 and 3. That's what I want to use, 16 and 3. Can you stay here? Thanks. 16, 3, negative 1. 4 root 3 I. Let me give you another one. Square root of negative 54. Please simplify that for me. divide by your perfect squares. So divide by 25, divide by 36, divide by 16, divide by 9, divide by 4. Find the largest one. Did we write down our perfect squares? We should have. We did not. Please do so. 4, 9, 16, 25, 36, 49. I try 16. Does 54 get divided evenly by 16? Nope. That's not a perfect square. 27 is not a perfect square, and 2 is not a perfect square. What is the largest perfect square, Mr. Cherba, that goes into 54? 9 is correct. If we take 54 and divide by 9, we see that root 9 times root 6 times root negative 1 is the same as root negative 54. We will now be able to write this as a simplified form, 3 root 6 times I. Now let's go back to the front, wherever we have space. We've already talked about solving x squared equals negative 16. We will have situations where we'll have like x plus 1 squared equals negative 16. Similar to the equations we were solving last class and for our quiz today. Okay? What would I do first? Square root both sides, right? I'd get x plus 1 equals, we know we need a plus or minus square root of negative 16. But this is not 4. It's not negative 4. This is 4i. And all of a sudden, I have something that has an I attached to it, and then I need to get this 1 onto the other side. I'll add negative 1. We will have what's called a complex number that includes both versions of I and real numbers. So I just square rooted, boom, plus or minus 4i, subtracted 1, I get this. So I get x plus 4i and x minus 4i. This will be our solution. Sorry, negative 1 plus 4i, negative 1 minus 4i. This will be our solution to this equation, both of these. They're tough. They're legit, complex. But it is the solution. We can use them. We can plug it in here, and it will solve that equation. Okay? Understanding these i's, you can treat them like variables, like x's. If I have 9 i's and I subtract an I, what do I have?
8 i's.
I have 8 i's. You're exactly right. If I have 2 and I add 11, what do I have? 13. This is just demonstrating that the operations are similar to with like variables. You need like terms. So you got 2 plus 11, 13. Sure, because they're like terms, I can do that. 9i minus an I have 8 i's. If I'm subtracting, make sure you distribute a negative. I have 5 plus 0 i's. Well, 0 times anything is 0, so I just have 5. All right, you guys do the next one, please. Tell me what 16 minus 13 minus 6i plus 8i is. All we're doing is just showing you that we can combine these like we do like terms with x's. Okay? Please do that. Making sure we distribute negatives. We add our common terms together. We can add our i's together. We can add our numbers together. We're doing this now. Distribute the negative. Combine your like terms. Okay. When I distribute this negative, that becomes plus a positive 6i. So I'm actually not going to take that negative 6i and add 6i. Your number was correct. 16 minus 13, 3. Okay. And you can go to the bathroom after this. Too many of us are careless with these negative symbols. You're not the only one. There's others. Add the opposite. The opposite. This is 3, yeah, most of you got that. But this is a positive 6i plus an 8i. This is 14i's. Come on! This is just a review of like terms. That's it. Nothing new. All right. Now let's get to the heart of the matter. I don't want to do this. I'm going to go straight here. This is not important. Multiplying is not important. This is important. This is what we're going to be doing. We're still solving quadratics. X squared plus 121 equals 0. What would you do first, Mr. Steck? What would you do second, Mr. Saripata? I would take the square root. But I got a problem. First of all, you take the square root, you need a plus or minus, but now we have the square root of negative 121. Split it into a positive part and a negative part. So I got positive root 121, and I have negative 1. See if root 121 is a perfect square. Wait, what? It is? What is it, Mr. Schumacher? Is it? Check with your calculator. It's 11. So, but watch what I do. Plus or minus, I got the positive root 121 and the negative 1. I do have solutions. My solutions are plus and minus 11i. If I plugged in 11i, square it, add 121, I get 0. If I plug in negative 11i, square it, add 121, I get 0. Mr. Black, what do I do first here? Subtract 25. Gives me 3x squared equals negative 200 minus 25. And is it negative 175 or negative 225? Step 2, Miss Brown. I got 3x squared equals negative 225. What should I do? What should I do? Let me ask you this. If you had an equation 3x equals 12, what would you do? What? You would do nothing? How could you get x by itself? Yeah. So 3x squared equals negative 225. What should I do? Divide by 3. Okay, everybody in your calculators, what's negative 225 divided by 3? I hope it's even. Whew! Thank you. Negative 75. Mr. Cherba, what would be the next step? X squared equals negative 75.
It's not per square.
Well, just tell me the next step.
Square root.
Square root. Okay, good. Now, tell me what I need to have on both sides. The left side will be, Mr. Chairman, when I square root x squared, what do I get?
Yeah, x.
Okay. And the right side, what would I need?
You got to do the whole thing again?
And we'll have to do it eventually. But I need a plus or minus. I'll worry about simplifying the negative 75 that's being rooted.
That's the answer.
Almost. I can simplify this. I can use an I, and I can simplify the square root of 75. So like the next step would be to write this as plus or minus root 75 and root negative 1. Please simplify the square root of 75. Question? Oh, you already simplified it. Okay, let's let everybody else get a chance to simplify the square root of 75. Again, take large perfect squares and try to divide them evenly into 75. Perfect. Yes. 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 Don't forget the plus or minus. We are almost there. It is the home stretch. Stay with me. The square root of 75 can be written as what, Miss Harvey? Beautiful. That's 5 root 3. X equals plus or minus 5 root 3I. We got it. We should have more examples than just one. We do have more. Oh, you have your homework. Sweet. I will be collecting your homework next class. 13. Step 1, Mr. Rasmussen. What should I do? Square root. Square root. Okay, so I square root both sides. I have x plus 3 on the left side. What should I write as my right side? First step, Mr. Rasmussen.
Square root of 36. Square root of 1.
Good. I like how you did that right away. Square root of 36 and the square root of negative 1. You are missing something. And this is important. Plus or minus. Very good, Mr. Charles. Plus or minus. You need that, right? Because an unknown value being squared, I can have a positive value to square. I can have a negative value to square to give me the value that I'm looking for. Okay, now here we go. I have x plus 3 equals plus or minus 6i. Add negative 3. You get x equals negative 3 plus or minus 6i. I can't take this 6 and combine it with the 3. I have to keep them separate. They're not like terms. What a Slim Jim?
So Jesse's beef snack stick.
Slim Jim.
You want one?
I'm good. Appreciate the offer. All right. Let's do another one just like 13. Let's go to your homework. Go ahead and cross off questions 12 and 13 and 10 and 11. If we have to do those, I'll come back to it. But I really hope we don't have to do those because I think they're just not necessary for what we're trying to do here. Yeah. Gosh. All right. What? There will be a key on schools. Whew. Easy 100, right, guys? All right. Put this on the back.
Oh, the very back.
Give me the solutions to this equation. Yeah? Who broke out their phone real quickly and snapped that to the school? Nobody? Good. All right, x minus 3 squared equals negative 16. I paused, don't worry. I know what I'm doing. Yes, sure. Pause the video. I would have done that too. I would have just been smart. X minus 3 equals plus or minus root negative 16. Listen, go ahead and look at the video. I would love the views. Do you know how many Algebra 2 views I get on all these videos I've been producing? 2! Probably less. What was that?
Someone like streamed the KSI Logan Paul fight off the glass. Oh, I saw that. Yeah. He streamed a video of himself.
Well, everyone else has to pay for it if you want to watch it. So, but he does.
There's a boxing match. Yeah.
Gotcha. Got it. Logan Paul, KSI. I'm feeling you guys. You can also like record it like through a mirror and they won't shut it down. Yeah, there's different ways. I find boxing streams all the time because I'm not going to pay for it. Okay, so I get plus or minus 4i. I add 3. I get 3 plus or minus 4i. Okay, cool. All right, let's go back. Let's go back. Unfortunately, we need to do this. I don't think it's not. I wish this was not included. This is my bad. All right. If I is the square root of negative 1, what is I squared? Negative 1. Okay. We already talked about how you could add complex numbers together. It's just like terms. It's the same, really, when you're multiplying. Everybody pay attention, because you're going to have to do this. 15i times negative 1. Well, negative 15i. 15i times 2i. If it was 15x times 2x, what would you say this is equal to? 30x squared. The 15 and the 2, the x and the x. 15i times 2i is 30i squared. But I squared is negative 1. So you can write this as negative 15i minus 30. Or plus 30 times negative 1. Okay? Look at number 10. Imagine I was asking you to take 2 minus 3i and multiply by 2 minus 3i. That's what you have to do when you're asked to square things. Let's distribute. Mr. Irwin, 2 times 2. 2 times negative 3i. Good. Miss Pierce, negative 3i times 2. Negative 6. I. Mr. De La Sencha, this is a tough one. Negative 3i times negative 3i. Negative 3 times negative 3. Positive 9. I times I squared. This is tricky. Hold on, we're not done now. We can combine these two i's, right? But what can I do with this I squared? I squared is negative 1. This turns into negative 9, and we're going to have to review this before our next quiz. Hey, you have homework. If you get like half of the homework done, I'll give you 100. And there will be a key online.